Okay, so for today, we're going to enter a new topic, which we will be talking about how to solve a simultaneous equation. Now, how do we do a simultaneous equation? It's going to be very simple. There are a few key steps you need to follow, and by following those steps, you should have no problem solving all these three equations. Now, let's start. Now, always in a simultaneous equation, you will always be given two equations, all right? And if you notice in one equation, there will be always two unknowns, which is y and x over here. So my question is, how do you find the value of x and y over here? All right? We can solve this by using simultaneous equation. So first, how do I solve this? How do I start? I will start by labeling my equation with numbers. So I call this as equation 1, I call this as equation 2. Now what I'm going to do with this equation is this, all right? I'm going to substitute equation 1 to equation 2. Now why do I do this? Once I write down my equation, you will understand why. So let's see what's going to happen here. So that's my equation 1 and that's my equation 2. I'm going to put this thing inside here right now. But how do I do that? Now take a look at my equation 1. My equation 1 over here, it shows me that y it's equals to 5x minus 3, right? And in my equation 2, that's also another y over here. So what I'm basically doing, I will be taking this thing in my equation 1, which is equals to y based on the first equation. I'm gonna put this and substitute into this y over here. Okay? So why do I do that? Let me write that down first. My equation 2 is written in this way, which is y is equals to 2x plus 15. Okay? So this y here right now from equation 2 will be replaced by equation 1, this one over here. So that's how I'm going to write 5x minus 3, it's equals to 2x plus 15. Okay? Now why do I want to do this step? Why is this step crucial when we are solving simultaneous equation? It is crucial because if you take a look at this equation now, we have only one type of unknown, which is x. Do you notice over here, we have only one type of unknown, which is x. We have eliminated the y unknowns, all right? Since we have eliminated the y unknown now, we can now find out what's the x unknown right now, okay? So from here onwards, it's going to be a very basic algebra question, okay? So I'm going to rearrange this by collecting like terms. So I should get something like this. 5x, okay, minus 2x over here, that's equals to 3 plus 15. Okay, that's what I'm going to get. All right, so I will continue to solve this. All right, I will continue to solve this. 5x minus 2x, that will give me 3x. And that's equals to 18. So my x value over here, that's going to be 18 divided by 3. That's going to give me 6. So I have found my x value over here. Okay? So right now, I will call this equation number 3 now. So since I already found x, I'm going to find y right now. Okay? So what am I going to do here? I'm going to substitute again. So I'm going to say substitute equation 3, which is this guy over here, to 1. Now, does it necessary I have to put to equation 1? No. You can actually put to equation 1 or 2. You will get the same answer, all right? You can substitute this to equation 1 or 2. You will get the same answer. I'm going to show it to you, okay? So I'm just going to put it to 1 because it looks much more simpler. So let's see what's going to happen. So if I substitute this equation 3 to equation 1, my equation 1 is originally this, so that's what I'm going to write. That's going to be y is equals to 5x minus 3. Okay? So since I know the value of x, which is 6, so this x over here will become 6 right now. So y is equals to 5x, which I know right now That's 6. Okay, minus 3. All right, so we can quickly solve this. Y is equals to 5 times 6, that will give me 30. 30 minus 3, that will give me 27. Okay, so we have solved for our value of y right now. In other words, we are done. All right, we are done with this question of simultaneous equation. Okay, so that's how we solve it. Now, just to show to you that you will get the same answer if you were to substitute to equation 2. So let me say I substitute to equation, oh never mind. Let me say I split over here. Let's just say over here I substitute to equation 2 instead of 1. So I will get y is equals to 2x plus 15. So we already know this x is going to be replaced by 6, okay? So y is equals to 2, and I'll put 6 over there, and plus 15. And true enough, 2 times 6, that will give me 12. 12 plus 15, that will give me 27 as well. Okay, you see? Once you find the x value, you can substitute back to equation 1 or equation 2, you will get the same answer. You can see over here, alright? But of course, for this example, I just substitute equation 1 lah, huh? Okay, so that's how we solve simultaneous equation. Now again, if you are, let's just say if you are not sure of this answer, you got this answer, and you might be wondering, did I do something wrong? You want to double check your answer. You can always put back all these values back into the equation to check if your answer is legit or not. So let's quickly do over here one time just to double confirm. Alright, so my first equation is y is equals to 5x minus 3, correct or not? I know my y is 27. Okay, my 5 is 5, my x over here, that's 6, and this is minus 3, and true enough, we can find this is 27 is equals to 27. It's true for equation 1. But don't be too happy first, because if your answer is correct, this, when you substitute x and y to this equation, it should be true as well. So let's just quickly check that, right, just for your reference. So my equation 2, it's y is equals to 2x plus 15. So my y again, we have found out that's 27. It's equals to 2. My x over there, that's 6 plus 15. And true enough, we will still get 27 equals to 27, right? So with that, we know that this answer that we get is the correct answer. That's how we solve simultaneous equation, okay? Now let's proceed to 2 more examples over here so that you can see different examples. Okay, but regardless of how the question look like, the working is the same step. Now what am I showing you over here is the longer way, but in my future video, I will show you a shorter way to solve simultaneous equation. But I feel it's important to know what is really happening here right now first, before I show you the shortcut. Okay, so let's go to here. Same question. I give you 2 equations. In one equation, I have 2 unknowns, and I want you to find the value of x and y using simultaneous equation. So my first step, again, I'm going to label my equation. That's going to be 1, and that's going to be 2. And can I do something similar to this? Can I substitute something to something? So let's see over here. If you notice that I have y over here, and I have y over here, right? So which means I can substitute this value, 3x plus 1, into this y over here, correct or not? So if I substitute, what will happen? I eliminate one of the unknown, alright? So I can find the value of x first, right? So that's what I'm going to do. That's what I'm going to do. I'm going to say right now, I'm going to substitute. I'm going to substitute equation 1 to equation 2 over here, okay? So which means this guy over here from equation 1, it's going to go in over here. Okay? That's my equation 2, which is written as 5x is equals to y plus 3. Okay? Now this y is going to be substituted by equation 1. So if I want to rewrite this equation, it's going to look something like this now. My y over here, it's 3x plus 1, but don't forget the plus 3 over here. Okay, so when you see over here, we have eliminated the y unknown. So we can find what's x now, right? So let's solve this right now. So again, we can collect like terms. So I can get 5x over here. I move 3x behind. And that's going to be equal to 1 plus 3. Alright, let me just write here for example's sake. 1 plus 3. Okay, let's solve this. So this will give me 2x. Alright, and this will be equal to 4. And x is going to equals to 2. Alright, so you have already find the value of x right now. So again, I will call this right now equation 3. And I'm going to do the same thing to find the y unknown here. So again, I'm going to substitute equation 3 to equation 1. Now again, I'm here to remind, it does not matter you substitute to 1 or 2, you will still get the same answer as I have shown you in the previous example over here. So I'm just going to put it in equation 1 because it seems I have less thing to deal with. Alright, so it looks much more simpler, so let's do that. Okay, so my equation 1 is y, which is the thing I want to find, is equals to 3x plus 1. Alright, so since this x is going to be substituted by equation 3, which is 2 over here, that's going to become like this now. Y, it's equals to 3, and inside this bracket, that's going to be 2, then don't forget your plus 1. So let's solve this very quickly. So y is going to equals to 6 plus 1, which is 7. And we are done. Okay, and then we are done. Alright. So again, like I said, feel free to cross-check. You can substitute 2 and 7 back to both of these equations, and you should get the same answer over here for both left and the right side. Okay? Now last example over here. This might look a bit funny looking over here. So right, don't worry, let's go through this together. Again, I'm going to call this equation 1 and I'm going to call this equation 2. Alright? So how do we solve this right now? If you notice right now, I can't substitute directly with what I did over here because there's nothing for me to do, right? If I say equation 1 substitute equation 2, it doesn't make sense, right? It doesn't make sense. So what can I do over here? Alright. Now there are actually few things you can do, alright, but I'm just going to stick to the basic for now and tell you what can you do over here. So if you notice over here, alright, I have this x over here, right? This friendly x over here. So we have already learned in an equation that we can rearrange equation to make a different unknown the subject now. Let's utilize that technique. To solve our simultaneous equation here. So I want to make, for this equation, I want to make x the subject, alright? I want to make x the subject, and then I want to substitute to this x over here, alright? I want to do that, but I need to make x the subject first, okay? So what do I do right now? So I'm going to say over here, I want to rearrange equation 1 to make x the subject. Okay, I want to rearrange equation 1 to make x the subject. So let's see what's going to happen now. So my equation 1, originally, it looks like this. X plus 3y is equals to 25. If I want to make x the subject, so x is going to be here, and that's going to equals to 25 minus 3y. Okay? Now, I will call this equation R1. Alright? Now, why do I call R1? Because I have rearranged equation 1. Okay? So that is how I like to write it. Okay? So right now, if you see I have this equation right now, it's going to look something very similar to this already, correct or not? So how do you use this information you have right now to substitute here? Alright? So let's see right now. I'm going to do this right now. I'm going to substitute R1, 2. Now where do you think you should put it? Now let's just say for some of you, if you think I should substitute the equation 1, let's see what's going to happen first, alright? Let's see what's going to happen first. So what's going to happen is this. Your equation 1 is going to be x plus 3y is equals to 25. And my x value right now, this x is going to become this. That's going to be 25 minus 3y plus 3y is equals to 25. So let's see what's going to happen, because what's the reason why I want to substitute all these things in? The reason why I want to substitute is to eliminate one of the unknown so I can find one of them first, correct or not? But let's see what's going to happen here. We can see that this and this will cancel each other. 25, if I move over here, that's going to be 25 minus 25. That's going to cancel each other as well. So what am I left with? 0 equals to 0, right? All my unknowns are gone. How do I continue to solve the simultaneous equation? So which means, what does this mean? Which means if you rearrange that particular equation, you cannot substitute it back to that original equation. Alright, if you do that, you will get something like this. Okay? So instead of substituting back to the original equation, I should put into equation number 2. Alright, so let's see what's going to happen now. So I have 4x, it's equals to 3y plus 10. Alright, and this x over here, alright, this x over here, this guy, it's going to go here. Okay, it's going to go here right now. So if you substitute, what will you get now? You will still get your 4. And my x right now has changed into this. Okay? So that's going to be 25 minus 3y. And that's equals to 3y plus 10. Okay? Now let's continue to solve this. We can expand this. 4 times 25. That will give me 100. And that will give me 12y, and that's equals to 3y plus 10. Okay, so right now I want to collect my like terms. All right, so I will get 100 minus 10, and that's gonna equals to 3y plus 12y. Okay, so what I will get here, I will get 90. And that's gonna give me 15y. Okay, so we can quickly solve this. Y, 90 divided by 15. So what do I get? Let me quickly check. Okay, so if I do that, I should get 6 over here. Okay, I should get 6 over here. All right, so I have found the value of y right now. All right, I have found the value of y right now. Now, like again, if you see over here, if you notice the first example, I find x and x first. It doesn't matter which unknown you find first. Okay, like in this case, I find y first. Okay, it doesn't matter which one you find first. Okay, because eventually your ultimate goal is to find x and y, right? So right now, I know that this guy is my equation 3. So what am I going to do now? I want to find my x right now, all right? I want to find my x right now. So I'm going to substitute. I'm going to substitute equation 3 to, let's just say, okay, now where do I want to put to? Everywhere is the same. You can put to this, you can put this, you can put this. It's going to be the same thing. Okay, so for quick example sake, since I want to find the value of x, I'm going to put to R1 instead, because that looks much more simpler because there's x over here. So my R1, that's going to be x is equals to 25 minus 3y. Okay, so I have x equals to 25 minus 3. I know that my y right now, that's going to be 6. Okay, so what do I have here right now? So I have x is equals to 25 minus 18. So that's going to give me Get 25 minus 18, that's gonna give me x is gonna equals to 7. Okay, x is gonna equals to 7. All right, so I'm done with that. All right, I'm done with that. Okay, just nice. All right. So once again, if you want to check your answer if they are correct or not, feel free to substitute all these things back into the main equation, and you should find both sides will be equal to each other. All right. So this is how we solve simultaneous equation. All right. And take a look. These are the most basic steps to solve simultaneous equation. In my next video on simultaneous equation, I will show you a quicker way and a shorter way to do this. All right. Thank you.